Okay, some more Haswell action. It wasn't that long ago when I showcased you how I've been a random 4770K CPU that I found online, which I thought to be at least somewhat good because it was from one of those quite reasonable known batches. And the thing about batch numbers has always been quite a debated topic. With the original Haswell 4770K CPUs, the batch number was actually really reliable to some degree. There were a few known batches among the earliest Malaysian batches for the 4770K that were known to be really good on average for overclocking. So if you found one of those known batches from like a local store or similar, you had a really good chance to get at least better than average CPU for overclocking. So with the original 4770K, it really did matter a lot. There were a couple of those very known batches which were really good for overclocking. People, when these CPUs started to come out to the market, people bought them in large quantities and they collected all the batch information and they shared it on sites like HWBot, mainly on the forums, and there people compared what kind of overclocking results they are getting with different batch numbers. And some of those very early 2013 Malaysian batches on the 4770K were really good. And I personally have quite a lot of experience with the 4770K and the early Haswell platform. I faced something really sad like 3.5 years ago when the original Skylake, so Z170, was already launched to the market. I tested many of these Asrock Z97 OC Formula motherboards over the years when Haswell was the newest platform, and I got one board from Asrock EU as a replacement, but however it wasn't like a brand new replacement board, like a full retail package. It seemed quite dodgy, and the sad thing about that replacement board was that the VRM, the V-core VRM of the motherboard was actually in short circuit, and due to that I lost my world record 4770K CPU that was really amazing chip. With that CPU I got the rank 1 score in like Hardware Pro Prime, like at 6.63 GHz with really high cache and really good memories, like 2800 to 2900 MHz on Samsung D-Die with the memories on LM2 as well. And I got the rank 1 score in GPU Pi, well technically in GPU Pi, but I failed to save the validation file, but I still have the screenshot of that score somewhere over here. And the CPU was also quite good for Cinebench and so on, like 6.4 or a bit over. Now if I could retry that CPU, I'm sure I would get a CPU frequency of of 6.4 or more with the modern thermal pastes and modern CPU containers like a T-Rex and so on. But back then, when I lost that CPU, I got really sad because that chip was just so good. It was really awesome. It felt much better than all of the bad Skylake 6700K CPUs that I tried. The 4770K, that known record capable CPU, was just so awesome, and I lost it due to bad board sample from Asrock. That CPU was one of those known batches of the early 2013 Malaysians. It was this batch, so L310B488. There were a couple of 488 CPUs posted by guys over at HWBot, but it wasn't as common as, for example, the L310B491, which, for example, the 8-pack from OCUK binned a lot in large quantities because that was more known really overclocking, really well overclocking batch. But the 488 was awesome, so I made a promise back then that if I someday see another 4770K with identical batch number, I will give my luck and I will try to buy it and see if I can get at least something close to what I lost around that time. And recently, like 2 weeks ago, I saw a 4770K to go on sale on eBay, and it had the identical batch number. Of course, the serial number is not the same, so the last 5 digits that are on the PCB, of course, they are different, but the batch number is same. So we have new, well, it's used, but new L310B 488 4770K, which should not be deleted, and the overclocking potential is quite a complete question mark, because the guy was using a very bulky motherboard, not really designed for overclocking and so on. So it will be quite interesting to see what it will do, because a really good i7 Haswell, so 4770K or a 4790K would be very good for like power chip and similar old DDR3 memory binning and overall overclocking use. So that's why I wanted to try my luck, and the price of this was really good. So it was only like 90 euros, and 90 euros for a 4770K in mid 2020 should still be a quite good deal. So here I can show you the batch number. So L310B 488, identical batch number as the one that died. So the box over here is the original package of the damaged chip. I will still be using the Asrock Z97 OC formula, although of course this is a different board than the one that was faulty. Back then when I realized the damage, I got a new replacement board once again from Asrock, but they did not give anything for the damaged CPU. So that was very sad. That was quite like bad point on Asrock's RMA or warranty system that they made a mistake. So it was really sad. So that was definitely something I wanted to try to tell Asrock that they should improve on. But still, when looking at the overall availability on Z97 motherboards, the Asrock Z97 OC formula is still, well, it always was kind of the best motherboard offering on that chipset platform. There weren't that many motherboard models on the Z97 chipset because it didn't differ much from the Z87, so there was no like Asus Maximus 7 Extreme option. The other like competitor models, like the reasonable options, were the Asus Maximus 7 Impact, the Gigabyte Z97X SoC Force, and the Gigabyte Z97X SoC Force LN2. The LN2 version would probably be the strongest motherboard of the whole platform, but it lacks the mounting holes near the CPU socket, so you can't really use it well just on water cooling or air cooling. So it's really annoying board to use. But it only has 1 DIMM per channel, so 2 memory slots, so it is, at least in theory, better for memory overclocking than the Asrock Z97 OC formula, than any any 4D motherboard out there on the market. The Maximus 7 Impact I don't like, even though it's 1 DIMM per channel board, but it's in a mini IDX format, and both the Maximus 6 Impact and the Maximus 7 Impact had a weird like posting issue that they could take up to 5 minutes to post memory settings. That was so annoying thing about that board. Like if you are on LN2, you have to wait 5 minutes for the motherboard to train your desired memory settings. That was really painful thing back then. I didn't like that at all. The apart from that VRM short circuit thing, the Asrock Z97 OC formula was definitely the best. It's good for CPU overclocking. It can do nearly the same memory timings and frequencies as the Maximus 7 Impact and the Gigabyte Liquid Nitrogen board, so it's not really far behind. On DDR3, 1 DIMM per channel design doesn't give you that much advantage as today on DDR4 with Samsung B-Die sticks. So that's why I will still stick with the Asrock Z97 OC formula, even after all the misery that I had with the board model. I'm not fully sure how many boards I tested in total. Maybe this is the number 6. Number 6 of Asrock Z97 OC Formula boards, but it's quite rare nowadays. The good thing about this board model is the conformal coating on top of the motherboard straight from the factory. So it has built-in insulation coating already from the factory. So technically you don't have to use like any Vaseline on top of this board. You can only use like your Armaflex insulation, paper towels, Inferno backplate and just go. But my personal advice is that if you put the RAMs on LN2, you should use some Vaseline near the memory slots, near the PCH and so on, because the when you put memory on LN2 like power chips and you pour them to full pot, that will cause you a lot of condensation issues. So it's better safe than sorry. But yeah, so this is what I got today. L310B488 4770K. I have waited 3.5 years to get another identical chip, another chip with identical batch number, and it finally happened, and for good price if you ask me. So let's get this board, let's get the CPU open up, let's take a close look at it, and then let's mount the CPU on the motherboard and let's get going and let's see how it performs. These CPUs are very easy to bin, so we will just see if we can do 5 GHz for SuperPi 32M with all cores and threads, and like 5 GHz for W Prime in Windows XP, and like 5 GHz for Cinebench R15 and 11.5. I still remember the results with my damaged or dead CPU. Before deleting, I could do like 5 GHz Cinebench R15 11.5 in Windows 7 with like 1.285 or 1.29 vCore, and with deleting it came down to like 1.27. So the target we are aiming for is really high. And well, it's not the batch is not only about the air and water quality. These batches are usually known to be good on LN2 as well, so they scale and they usually have great code bug. The mainstream Haswell 4770K and 4790K, they have the FIVR, so they cannot run full pot. So the best CPUs will have a cold bug around like -135 to -140 degrees Celsius. So it depends on luck how cold we can push the CPU. We still have the original sticker and the original cooler, which we will not be using obviously. So here you can see the CPU in close view, so you can see the batch number. So L310B488. 8-pack from OCUK was famous for binning these CPUs. He even sold like personal speed binned 4770Ks on OCUK, and they were mainly L310B491 batch CPUs, then like L318B CPUs, I don't remember the last 3 digits, and then some like L316B batch CPUs. And then there were some really good CPUs among like L311B and L315B batch, but all the golden CPUs when it comes to 4770K SKU were among the early Malaysian chips from 2013. But yeah, so that's the CPU. Let's hope it will do well. But of course, not every CPU, even from a known batch, will be golden. So there's real chance that this CPU will be very bad, even on water or air, like not even doing 5 GHz for Cinebench and so on. But let's see, let's keep fingers crossed and see how it will do. But I will put the CPU now to the motherboard. I will mount the motherboard on the test bench and let's see how the settings look like in the BIOS. Let's look at the VID value and how the CPU performs. Okay, so here we are in the BIOS, so we can see we are using an Asrock Z97 OC Formula L1.12D BIOS with 4770K. And if we go to the hardware monitor tab, we can read stock input voltage of 1.76 and the V-core VID is lower than 1 volt. Like blinking between 0.97 and 0.992, so I would have to use like a multimeter to check it accurately. Could be a touch better, I think. The core one is blinking 0.976, but I can check this with it with a multimeter because there's surely some variation between the boards in the measurement accuracy, but at least it's lower than 1 volt, so we could have some good luck, but it really depends on how well it overclocks. CPU temperature 26 degrees Celsius. So I will get on with this. I will try to boot the operating system and let's see how this performs. Okay, and this is what happens when you boot a recycled operating system too many times with different platforms. So this is one of the moments where you really need a PS2 keyboard. So we can load all the default drivers so that we can actually start using this new platform with the same operating system. I measured the V-core with multimeter and the stock VID is around like 0.98. A bit same what CPU Z was reading like a brief moment ago. Just have to wait. But VID is always just like initial value. It's not a true indication of overclocking quality. We still have to test the CPU itself, but generally you want to have a value less than 1 volt. The CPUs that have higher value than 1 volt, they weren't good enough generally. I think the previous one, I don't remember it fully, the which I used for the binning video, I think it had a VID value of like 1.04. So this is significantly better than that, but we have to test it ourselves, and we have to test everything ourselves, and we have to move up like slowly and carefully because of the temperatures. If the CPU is not deleted, they will run very warm. The low VID CPUs are generally quite high leakage, so they draw quite a bit of current at given voltage, so that means they are generally really warm CPUs. So let's try, just purely out of interest, test the stock temperatures. Core voltage should be reading somewhat okay. Let's try stock W prime, 8 threads, 1.044, 40 degrees. Of course, well, this is just a stock, so we have to start from something and let's see how it overclocks. So a really golden CPU will run 5 GHz W prime in Windows XP environment at around like 1.2 volts. I think the Dankop CPU was like 1.17 volts with delete and everything for 5 GHz W prime 1034M. But really the target is insane what we are looking for. Now this will be the moment of truth. So 5 GHz on the core, all cores, and 45 on the cache, 100 base clock. Just max the power limits and so on. Make the set the FIVR to max. Disable all the efficiency things. 1.25 on the V-core and on the cache. The stock value of the system agent voltage on this particular chip is extremely low, 0.8 volts. That's probably the lowest I ever saw on any Haswell CPU. But I'm not fully sure because it's so long time since I really used this or ran these CPUs. 1.91 volts. The stock input value was really low measured by multimeter, like 1.73. It's really low value. So let's try these values. If this boots well, then we should be in a good playground. If it fails, then it will be sad. But it should boot these if it's at least somewhat good or really good CPU. Okay, so sadly it doesn't seem that good. The 4.9 goes well. 4.9 is very easy at 1.25 volts, but 5 GHz really starts to require a lot more voltage. So far, like 5 GHz double prime, we are looking for 1.32, 1.33 volts. So this CPU isn't really that much better than the one we used before on the previous Z97 overclocking or binning video. So let's try one more time. So this is at 5 GHz, 4.4 or 4.5 on the cache. Let's try this shorter one. I think it will crash. The VCore is 1.322. So yeah, VID should be a bit lower to have better chance, but it's not only about VID, it's also about the scaling. Temperatures are already well over 70 degrees in this test, so I think I should try deleting and see if it helps even a bit. Like, does it scale well with the temperature drop if we use liquid metal? That's also one thing of note with these CPUs. 70 failed. Max temps very high, ranging from 63 to like 71, so the range is really high. Let's try this way. 8 threads and there. Almost. Well, yeah. And now it finally passed, so yeah, it's very on the edge. So without deleting, W prime 32, 1.322 volts. Yeah. So let's check. So 1.322. Not really good, to be honest, but well, that's what it is. So yeah, this CPU is definitely not a hyperthreading monster. I can say that for sure right now. If I remember correctly, I did not bin the previous L310B488 before deleting on W prime, but I remember that it was like 5 GHz for Cinebench R11.5 with like 1.29 volts, and that is harder to pass than Cinebench. I mean than W prime. But we can try like 2 cores performance, because the CPU could have 2 amazing cores for SuperPi and so on, and that's also one thing we like worthy of benching. It's not only about hyperthreading. Some CPUs were multi-threading monsters, and some CPUs were really good for single core. The previous CPU that I had, the L310B488, it was an absolute monster for hyperthreading, but max it could do for SuperPi 32M was only like 6.5 to 6.6. It was worse than what it did for hardware prime. That was really weird. So let's see with 2 cores. So let's try like PiFast or SuperPi. So let's try 51. Same voltages, 2 cores, 1.29. 1.91. So yeah, the core seems really bad, so I cannot even boot like 5.1, no matter if I have single core enabled, 2 cores enabled, or just 4 cores without hyperthreading. So I'm not fully sure if there's even point to delete the CPU unless I want to sell it and the new owner wants it. But the IMC on this CPU seems really good. Now running 2800 MHz, 8.13.8 with good sub timings. 8.12.8 crashed at loop 3, but it's TRCD limit of 12 at around 2800 MHz. To pass that, I need a bit cooler ambient temperature, like 2 degrees cooler, because TRCD is only tied to memory stick temperature. But this seems to be stable, so let's cancel this and I will show you. So just for memory testing, 5G, no hyperthreading, 1.35 volts, 4.5 cache, 2800 MHz, 8.13.8, 28, blah 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 blah. These are the Patriot 2500 MHz 9.11.9 sticks. Okay, so now I'm in the server 2012, the recycled operating system once again, but shouldn't matter. So 5 gigahertz, let's try that in Cinebench, 1.33 volts, but I think it will crash. This is the last thing we will try. So 1.33, and boom, instant failure. So it tells a lot. Yeah, I mean already. So I think it will need like 1.35 plus for this. So yeah, so the core of this particular CPU is just absolute crap. So even 4.9 is failing Cinebench R15 at 1.37 volts. And the temperatures aren't that bad, to be honest. So let's try to run it a bit now. So like mid 70s, from 67 or 68 up to 77. And this failed after like around midway, at around like 60%. And 5 gigahertz is instant failure with this voltage. So this is really bad CPU, like core wise. The only good thing about this particular chip is the IMC. The memory controller inside the CPU is literally awesome. Probably the best IMC I have had on any Haswell CPU this far. At least the same what I had with the dead L310B488. So yeah, so 980 Cinebench passed, and if we raise the clock to 5 gigahertz, so 50 multiplier, 1.95 input, 1.37 V-core, and this should be an instant failure. And it is. So really bad CPU core wise. So yeah, really bad CPU, at least when it comes to the actual core of the CPU. When I tried to cache, I was able to run like 4.9 gigahertz on the cache for SuperPi 32M and so on, with 1.4 something volts on the cache. I was able to run the test with 5 gigahertz on the cache for some bit, with really high cache voltage of like 1.55, but that's already quite dangerous value for just water cooling. So I wouldn't run that any further. So quite good result on the cache. 5 gigahertz is really rare on these mainstream Haswell CPUs. So even 4.9, quite good result for that. But the core is really bad. It's worse than on the previous 4770K that I tested, which was the L315B. So this is really bad scaling wise, although the VID was somewhat reasonable. But I think this is a relatively low leakage CPU because the temperatures were so good, even with 1.37 volts on the CPU, considering that the CPU is not deleted. The identical batch 4770K that died had temperatures of like 85 to 90 degrees at 1.28 volts before deleting, so with Intel's own TIM. So the difference in temperatures is really huge between these two CPUs, although they are identical batch. So really bad CPU. I also tried to boot 5.1 with and without hyperthreading, and also by disabling cores from 4 to 2, and it could not boot Windows XP at all, even with like 1.3 volts. So that is a really bad result. So the core just did not want to move above 5 gigahertz at all. So when it comes to all cores and threads, only like 4.9 in Cinebench R15 and so on. So not really good. No 5 gigahertz or something. I mean, no 5 gigahertz or anything like that. Then for W prime, I think it might pass 5 gigahertz with close to 1.4 volts on the CPU, but 4.9 to 5, pretty much the same result as in Cinebench as well. But so not really good, considering what the absolute best CPUs can do. The only good thing about this CPU was really the IMC. The memory controller inside this CPU is just absolutely amazing. I did so amazing figures with my golden Patriot Viper 2 Sector 5 2500 MHz Cas9 sticks. I have never done anything like this before on any power chip based DDR3 memory, so I learned something new when I used this particular chip with those memories. I have 4 sticks of this particular bin in total, so 4 sticks of Patriot Sector 5 2500 MHz Cas9. Then I have tons of different G-Skill Pi series sticks, so I have like different bins, so 2000 Cas6, 2200 Cas7, 2400 MHz Cas9, and they aren't as good as these 2 Patriot sticks that I used with this particular CPU. So I did up to 2850 MHz stable in SuperPi 32M with 8, 13, 8, 28 command rate 1 timings, and all of the sub timings were really tight. Even the very important cache write latency was running at value of 6. Value of 6 is really tight on that setting, so that was amazing result. 2860 MHz was very close on passing. I crashed always at around like loop 16, so that is pretty much the limit. So then I would have to just get the memories colder or just increase the voltage, but the voltage was already so high that I was feeling quite scared. The funny thing about those Patriot sticks was that they actually scaled extremely high with memory voltage. Usually power chip based memories stop scaling wise after 1.96 volts on the memory. So after 1.96 they usually become really unstable. That's the common thing with power chip based memories, or it could happen even earlier, like 1.95, 1.92. But these Patriot sticks scaled all the way up to 2.08 volts, so close to 2.1 volts on air. Just air cooling with custom heatsinks. That's extremely weird result. And really that megahertz what I ran with them just on air cooling both on CPU and on the memory is something no one else did before, at least that I know of in the community. I also tried 2900 MHz with same timing, so 8, 13, 8, and all of the sub timings were the same, and I was able to run SuperPi 1M stable. SuperPi 8M failed quite fast, and SuperPi 32M was an instant failure. And then I also wanted to try to post 2933 MHz, so the next multiplier after 2800 MHz, but it was instant failure, so it couldn't even post. But that's something you would expect, really. And why TRCD of 13? The TRCD value is only tied with temperature, so you cannot make it tighter by increasing the memory voltage. And the TRCD limit of 12 with these sticks is around 2000 MHz, which is the best level any power chip based memory can have. So the absolute best power chip based memories have a TRCD limit of 12 at around like 2000 MHz. With these particular Patriot sticks, the limit is at around like 2810. They can pretty much always run 2800 MHz with 8, 12, 8 timings constantly. So that's really high. But 2850 to 2860 max frequency, that's something I have never run before. I was so amazed by that result, and I learned something new when using this particular chip with those memories. But yeah, so I don't really need this CPU. This CPU is way too bad core wise to have any chances on like good scores on LN2, so there's not really any like benefit to even delete it. Deleting this CPU will not give me anything, like it's nearly useless. And there's no point to try it on LN2 either. The only thing that I could try with this CPU is to run it on LN2 with the memories on LN2 and just see how far I could push the memories on LN2 in the 5 GHz SuperPi 32M competition. So could I run the Patriot sticks like 2900 megahertz plus with Cas5, so like 5106 or 596 timings. That's the only thing I would like to try with this CPU, because this CPU has probably the best IMC out of all mainstream Haswell CPUs that I had. At least the same level what the dead chip had, but I think this is the best IMC out of all Haswells that I ever tried, including 4790K and the Pentium G3258. But yeah, so to conclude this video, batch number will not guarantee you anything, although with these mainstream Haswells, batch number can usually give you quite good chances to find at least somewhat good CPU. But even if you find a random CPU out of a known golden overclocking batch, there's no guarantee that that CPU will be golden as well. But it just increases your chances to find at least better than average CPU. And even this CPU is not completely like complete trash. Many Haswells can't even run 4.5 GHz for Cinebench, or they max out at around like 4.5. So this one was doing like 4.9 to 5, probably 5 with deleting. So it's not bad, but it's not golden either. So it doesn't really scale with temperatures, although the VID was quite good. So that's pretty much the end. But at least I kept my promise. So I promised myself to try another CPU of this particular batch if I ever found one, and if I was able to purchase it for a reasonable price. So yeah, good IMC, very nice memory results, but the CPU is bad. So if you have any comments about this video or questions, then please drop them down below. But other than that, thanks for watching once again, and I will see you on the next one.